welcome to the session. Greeting of the day. In today's class, we are going to talk about the types of defects in welding processes. We have already seen the various welding methods of arc welding methods, resistance welding, solid state welding, and other methods of laser and this electron beam weldings. In total, out of this all, in welding defects will come during welding and after welding processes. So precautions to be taken to avoid these defects. So what are the defects available, first we should know. Then accordingly we can take actions to repair or prevent. I have here divided the various types of defects into such 10 categories. About 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. How I have divided, you see, I am classifying as a first initial point. We want to take two specimens and we are going to weld. The defect started at the fit-up itself. When we are trying to connect these two, at that point itself the error comes when the misalignment of setting happens, misalignment of fitting process happens. That I have given as a setup irregularities. And then later I am dividing as a surface defects, whether it comes in the weld zones in the various surfaces. Here we are going to weld. In this zone we are going to weld. I am going to weld here. So what are the surface defects are available? The name says everything. It is incomplete filled groove. So we know this is groove, edge preparations, V groove, U groove, J groove that we are taken. Single groove, double V grooves that we are taking. But incomplete filled groove. Here the groove is not filled by the filler material. Incomplete fusion. It is failing surfaces are melted, but it is not fused weld. So that is one of the other defect. And then overlap. We are doing more. Instead of doing this zone, we are doing simultaneously here also. That is overlap. We will see one by one. Excessive reinforcement. This is reinforcement. Above thing is reinforcement. Yes, excessive, improper reinforcements. And then I am coming. This is the surfaces. Now I am coming to the bottom side. In the bottom side also similarly we are going to do the welding process here. So what are the chances of defect in this case is lack of root fusion. We know we are giving the gap here of 1 mm, in 1 or 2 mm in such a way the electrode will come down and weld. Due to that gap changes, the root fusion may not happen. This is a root to be properly melted and then welded. It means 100% full penetration to be there. It means total 10 mm thickness to be welded. If the root is not welded, the 1 mm may not be welded. Therefore, it will be welded up to 9 mm only. Then it is a defect because full penetration is not done. So lack of root fusion. Similarly, lack of root penetration. And then excess root penetration. What I am doing, I am welded, but I am doing excess up to these things I am doing. Here I have welded properly. Here the surface are welded properly up to this limit. Here it is not excess. Excess reinforcement is not happen, but excess penetration is happen at the bottom. So these things, excess reinforcement, excess penetrations are related. One is at the top, one is at the bottom. Concave root. Root become concave at the inside. So burn through, root oxidations. So likewise in the root side defects. One I am talking about the surfaces, one about the top, and one about the bottom, one about the fit-ups. Then I am coming to the profile defects, how it looks. This undercut will form during welding process. Then the start-stop. We are doing a welding process by this using this small consumable 450 mm electrode. If it is consumed, we should stop welding. We should replace it with a new one, and again we should start welding. So this stop and start problems will be there. The images I will show you. So as patterns will form, arc strikes will be there, crater pipes will be there. These are all about how after the weld bead looks, profile how it looking, profile defects. Then later I am dividing into solid inclusions. In SMAW process, we are using this flux items. These flux are converted into slags with respect to light density. This light density fluxes will due to improper cleaning actions, this fluxes will also become the part of the weld and reduces the mechanical property of the material. This should not happen. Simultaneously, this is for SMAW. Now I am using TIG welding process where I have used tungsten inert gas welding. So the tungsten, when I am using very sharp corners I am doing, due to high heating, this sharp corners, there is a chance to break down and fall into the workpieces. So this is a tungsten inclusion. So totally I am telling us a solid inclusions. It may be a slag inclusion, it may be a tungsten inclusion. This all is to be avoided. One by one we have to see all this. See how many? 10 in total in general, but inside we have 5, here we have 5, here we have 6. So many are there. So the cracks. The crack may be the longitudinal crack, transverse crack, crater crack, throat crack, toe crack, root cracks. These are hot solidification cracks, cold cracking, it is a delayed cracking. All cracks are possible due to shrinkage effects. Alloying system will solidify according to their melting point, their solidification freezing points. So the alloying systems to be mingled accordingly. If temperature gradient is too large, one material will melt, one material will solidify, and one will not mingle with the other one. At the time, it is not mingling with the other, that is the crack. Otherwise, it forms a shrinkage. One is shrinked, solid, it becomes solid. One is in liquid, it's not shrinking. And then it is a shrinkage. It forms the crack there. Both are not mixing. So such cracks are also available. And then at last I am coming to the gas cavities. So we are using the shielded gases, shielding gases of CO2 in the SMAW process. If the shielding is not possible to comes out, or hydrogen embrittlement with respect to atmospheric involvement. So this type of defects, gas evaluations will happen, such as herringbone porosities, clustered porosity. Maybe if it is small, then we call it as a cluster. If it is a large one, then we call it as a blowhole, root pipings. Later we can able to see the 8th one as mechanical damages. Even after welding process, we have to remove the slags, we have to grind, we have to profile defects to be proper smooth surfaces in the weld. So we have to grind those things. So grinding also will cause the damages. Even it is specifically we are doing grinding operation to remove these slags, remove these profiles. That grinding operation sometimes will hit the base material. So irregularity will be there, wrongly grinding will be done. Due to this employee's lethargicness, so that mechanical damage will come. This all with respect to welding. But in the base material, the 9th one, in the base material itself, when we are purchasing and when we are casting, this laminar tearing, laminations, 2 attachments won't be there. It will come as a base material defects. And the last one I had as a heat affected zone microstructural changes. In welding, this heat distribution occurs throughout the welded specimens. We know heat absorbed and melted and deposited, that is okay. The remaining part of the heat will be distributed throughout the A specimen and B specimen. This heat distribution will also will be rapid and will be rapid cooling. So this change in the microstructures, dentate formations or martensite formations. So this microstructural changes causes the changes in the mechanical properties. So that it all comes under defects. If the property is good, that is okay for us. If the property is not good, that is considered as a defect, and we should remodify the heating and cooling systems. How it is should be cooled, how fast, how heat input then we should do, high heat input not recommended. Such cases we should do. So that is a heat affected microstructural changes defects. I have divided into 10 categories. This we should understand. Each having 10 into 5, or you can count 6 into 7. 7 into 5 defects are there. So we have to see one by one. I'm just first I'm starting with this setup irregularities. I'm starting. Setup irregularities. You see, here it is a linear misalignment. It is a linear misalignment. It's measured from a lowest plate to the highest point of the gap. You see here, I have, this is a straight to be made. But what happened? The misalignment happened here. Actually, two butt pieces to be kept parallel in equal height. But here there is a gap of linear misalignment. Linear right. Now, what are the other chances of doing the fitting process? The fitter will not fit like this uniformly, but he is just like that due to this lethargical, he is fitting in this way. But the welding is done. But here the misalignment happened. Similarly, angular misalignment may also possible. You see, angular misalignment, how this angularly two workpieces are not flat. It is kept aligned in this way. So state is here. State is here. How they have did it. This is angular misalignment object. What is the precaution? They have to fit properly, see, check, and then they should do. That is the precautions. It is a physically damage. It is not a metallurgical damage. It's not happened due to heating. We have not yet started the welding. But there itself the error comes. It started here itself. It is not the design. Design is straight. By the design, it is straight. But the design itself they are doing wrong. Then how this gives the properties? Next I am going for the linear misalignment. You see how this, likewise one more image I want to show you. So this is the linear misalignment. You see here we have a kit of one specimen and we have done here highest point of the cap. You see here this one height. Similarly, this both varies. When the misalignment happened here, the capping also happens. This is the capping height. Here also it is obviously changing. Here we have done wrong. Here also it is obviously changing as like this. Right? So what is the causes here? Causes due to carelessness of the welder, fitter. Also due to the joining different thickness sheets. Joining a different thickness. This is one is we will consider this is a 10 mm. And one more I am connecting of 7 mm thickness. So both will not match, both will not equal. At that time this type of difficulties will come. That is to be taken care. And then how we can do this repairing or precautions? It should be gun grinding. It is difficult for inside piping and tubes. That is the idea. Inside we can't able to do. Outside we can able to do grinding. In case it is pipe joints, we can't able to go inside and do weldings. Therefore, some grinding also not possible. So outer side we should take care properly. So that is one. Now I am coming to this one we have done. Now I am coming to the surface defects. Here this 5 we have to see. One by one we will see. Now the surface defects. Number 1, lack of fusion. Lack of fusion. It means, you see, in these images, incomplete filled groove plus lack of side wall fusion. The name says everything. Lack of side wall fusion. Where is side wall? This is one side wall. This is one side wall. An incomplete fill. Here it is not filled. How we find it is not filled? See, the edges are not even melted. This two specimen as edge prepared it is there. These edges are not even melted. It means heat is not even supplied there. Heat is supplied here and welded. Here heat is supplied and welded. Here it is welded. But this point the surface, fairing surface itself not melted. So it is an unfilled surface and also lack of side wall fusion. This is side wall. That is why I am naming this as a side wall fusion. Second one, you see here, lack of side wall fusion and plus lack of inter-run fusions. This one belongs to this one. This one belongs to here. A lack of inter-run fusion. See the one is a lack of side wall. Here it is not filled. Number 1. And number 2, lack of inter-run fusion. Here it is not even filled here. This blue color you can able to see. How it happens, why it happens, because the idea in the SMAW process, the slag is not cleaned properly. If the slags are not cleaned properly, how the second layer of weld, here I have done welding process, the slag formed of the higher layer, one electrode is consumed here, next electrode we are changing and we have to weld in these locations. Next layer, next 450 mm we have to weld. But in between the slag is formed for that 450 mm plate. That is to be removed, slag to be removed, and then the slag uses for protection. Welding over, slag to be removed. When it is removing due to this welder lethargicness, the slag is not removed properly. Then it is inside. Above this I am going further. So it is the above layers are not matching with the below one. So that is called as a lack of inter-run fusion. It is in the middle. That is lack of fusion only. Commonly lack of fusion, but specifically lack of inter-run fusion. This is lack of side wall fusion. Where the location, according to it names. So the causes, the poor welder skill. That is what I told. And also fast travel speed also. If you are welding too much quick, heat, sufficient heat is not given to the specific location. Therefore, these problems will lack of fusion will occur. Fusion, melting should occur, then only to deposit. We are not even given the permissible time to melt. Incorrect electrode is not used. Correct electrode 7018 for same, that is not used. Arc blow due to incorrect welding and current. This high current, high heat. Proper current is not given. Incorrect travel speed. So travel speed incorrect. It will optimize travel speed to be given there. Incorrect inter-run cleaning. So this is what we have to clean properly by the welder. But they are not done. Well, how we can able to do this? Repair. Eliminate the potential causes. These are the potential causes which is to be avoided. The welder is cleaning properly. This inter-run, lack of inter-run will not come. Very simple. But these things we are not doing. It reduces the mechanical property. It is not joining and causes the defect. Again, this is totally cost investment is waste. So a few images I want to show you here. See, this original images. Here, lack of, this is, we have seen about a simple sketch. And now I am showing you how this original specimen looks. Here the two specimens I have taken and welded, and it is cutted. And the cross sections I am seeing here. In the cross section you see here the lack of side wall. This is specimen A. This is specimen B. Two specimens are there here. You can able to see the small line of black spots which is not welded. Here the sides, it is not welded there. So that is brought to lack of side wall fusion. Similarly, lack of root fusion, lack of inter-run fusion. See, lack of inter-run fusions are here. So this point you see, lack of inter-run fusions, visibly you can able to see there. So likewise it forms the same, the curvature I have seen, I have shown you in the last image also. So that is inter-run fusion. So likewise. And then I am coming to the next one of overlap. How this is formed. We have seen about the lacking of fusions. Now you see, here we no need to weld. The groove is up to here and we want to weld from here to here only. But what I have did more melting process at the corners. So that is what here, that is what called as overlapping. How this is formed. Similarly, welder skills. You see, contaminations, it is not mixing with the grooves. Then the slow travel speed, optimum speed needed. We are keep on keeping at the same location. What happens? It is melted, deposited, melted, deposited. Melted, it is deposited there itself. Then where it will go? It is over. It's overlapping on the same location. That is named as simple overlapping. The name says. So it means it should be optimum speed to be given for these cases. Then incorrect welding technique. The correct welding methodology we have to choose. Current very too low or too high, irregularity not to be there. Prevention, how we can prevent? Proper welding technique we should choose to do this exact welding methods. How we can repair it comes prevention, we are choosing the proper welding methods. How we can repair? We can able to repair by smooth blending on the base material. So what I am doing the grinding operation here smoothly. So smooth blending operations I can able to do here. Smooth blending operations. So that is how we can able to avoid. Otherwise it becomes test corners because it is a sharp there. It is closing like this. It is a sharp. It should not be like that. So what I am doing, I am making smooth. I am making smooth process there. So see how this in the L joint, corner joint. So how this overlapping comes outside. See, this is the exact location, but this projection comes due to welding or keep on overheating at the same location. Here itself more deposited. Here is the filter, more filter is deposited here, more electrode is deposited. So it is this called as a toy overlap. At the corner they are naming as a toy. This corner is named as a toy overlap. Next I am coming for the reinforcement. So we have seen about inside fusion, lack of fusion. Reinforcement, the top you have to see. See, the amount of groove weld which is extend beyond the surface of the plate. So we know this is the height. So this is the height of 10 mm, 20 mm, that is thickness of the plate. So this is the thickness. And then what we are naming is a reinforcement. You see, this zone is called as a reinforcement. This height we are naming as a reinforcement. Keep remember. So this reinforcement is a surface to reinforcement, is a root reinforcement, but the bottom is a root reinforcement. The surface at the top, root at the bottom. So how it can be maybe excess reinforcement, maybe insufficient reinforcement is not filled. What I am doing the welding up to this only. Here I have completed the welding. Here it is not did. Improper contours. So that we have to maintain properly. First one, of excess reinforcement. Typically reinforcement should be flushed about 1/16 inch of flush or 1/8 inch of the plate. It should be, they are measuring up to 1/8 of the inch, 2 mm or 1.5, 2 mm, you can tell. So causes travel speed, why it is caused those things of excess reinforcement, high current, too slowly we are keeping overlapping and this reinforcement are similar. We are keeping as it is. More current is given. Speed is not there. Melted and deposited at the same locations. Deposited here itself. Here itself it is keep on depositing. You should move. Welding is over here. Welding is over. Unnecessarily we are depositing more there. This is a reinforcement height. This is height. So this is extra. This is extra. That is to be avoided. So travel speed is too slow, and then we can able to tell the amperages are too low or high. Prevention, how we can prevent this? Set the amperage and travel speed optimum. That is why we can able to divide or solve. So on scrap plate by trialing, how it will come if this current and voltage I am fixing here. How much penetrations, how long I should keep it should be practiced by the welder. Because after practicing he is doing, that will be perfect. He is unknowingly doing these errors. He is new. He don't know how much depth he should keep the hands here, manual welding. Then how many seconds he should move, travel trainings to be given, speed trainings. Repair. How prevention, this should not be done. Repairing, okay, it happened. We should repair. Rather than first, preferably is prevention. Otherwise, if it is happened, we should repair those things. For that, we cannot able to reject. Welding rejection is costly. Those who we are grinding and then removing this top flushes and then we are using. So that repairing we should do. Remove excess reinforcement, we are removing. These things we are removing. Grinding operations we are doing and we can use. So that is how we can able to utilize this. Insufficient reinforcement. Typically underfill maybe 5%. Little bit we can accept. 5% out of 110 mm we can accept little bit. 5% of thickness are not exceeded 1/32 inch. Sometimes it is called as a root concavity. How it is caused then? Similar patterns. On root reinforcement, too little fillers. Filler material is not used sufficiently. Electrode is not used sufficiently. Even heat is there, everything is there. It is to be melted and deposited. If it is not melting, we are going very fast. That time also it can happen here. Filler to be used there. If it is not melted, then it is not possible. Too little filler material causes the thinning of the fillers. Amperage are too low, it is not melted. Amperage are too low. Current to be given, even I am keeping filler weight for the given time, but current is not supplied, filler will not melted and deposited. Optimized current, melting and depositing and optimized speed. This will help for the good weld. How we can prevent then? Use proper welding technique, use the backing or consumable inserts and use the backing to cover the specific welding processes. See here how this images. Improper reinforcement weld contours. See this one. This is improper weld contour. It is coming downwards. There are other defects are there. So blowholes is there. Okay, here also some overlapping is there. But what I'm telling you, what I want to tell you here is about the weld contour. Weld contour to be smoothly welded. Weld contour to be smooth. It should not be sharp. This 90 degree should not form there. This 90 degree should not form. If this causes the crack initiation points. Sharp points are crack initiation points. Stress creating points. It should be blended. So it should be smooth, then the stress creations will be less there. So when the weld exhibits less than 135 degrees transmit angle at the weld toe, causes a poor welding technique. So we have to do smoothly. Welding methods, tricks. This welder skills is important here. Prevention, use the proper welding technique, use waving motion. Don't do it by like this. Slowly you can shake hands. Slowly you can move hands in such a way, the weld will come in the blended format. Always we keep on increasing. The penetration thickness to be welded, that is accepted. But for that we can't able to do like this, keep on going. So lightly we should blend. Then we can, blending happens like this, then we can able to move. So welding technique, some method of welding techniques to be followed here. So that's what. See, this is other techniques they are marking as gas porous, cold lapse. So here overlap or cold lap, this point. So that is our initiation point is this one. Now we have done about the surface defects of incomplete field group, lack of fusion, overlap, excess and improper. And then now we are coming to the root defects. How it is happening, the lack of root fusion and this lack of root. Surface we have seen, root we have to see. The remaining part of the subjects we will see you in the next class. Thank you.